Guys, so we're going to go through the space prep. I apologise, there's been a bit of confusion about the mark scheme and the answers here, and looking at it I can see where it's come from. So we are, because you're an amazingly clever set, we're looking for aiming for grade 8 on space here, which is the grading system to 9. So 9 is like an A star, A star. There is no aiming for grade 9, so grade 8 is the highest in these worksheets. Okay, so we're looking at space and we are hoping to be able to revise stars, a bit of red shift and about the universe. And the confusion here is this is an overall answer sheet, and because we're aiming for grade 8, on the right hand side we've got the answers here, and we're going to go all the way down to aiming for grade 8. Where are we here? Okay, so here we are. So what I'm going to do is I'm going to go through the answers on the left using the answers on the right, and then we can work out if there's anything that we need to specifically have a mind to. Let me get the correct mark scheme thing. Okay, so the other thing that's a bit weird about these is some of these are a bit practically, and with COVID we're not able to do the practicals necessarily, so a little bit of imagination is required. Okay, so task 1 is the solar system stars. Write a set of quiz questions that answer as many questions about the formation of the solar system and what happened to the sun as possible. You should include the formation of our solar system, how our solar system will be when the sun reaches the end of its life cycle, the process that produced the planets, the process that makes the sun shine, what would happen to a much more massive star. So you can see here on the right hand side you've got some examples of the kind of questions that your answers you might have. So for example, they came together to form a protostar. So let's just go through this process of how this happened, and then you can just double check that you are okay based upon these questions. So if we go back to a blank sheet here, we've got our hydrogen, okay, which is forming a cloud called nebula. There is going to be movement and slight kinetic energy, and then they are going to collide with each other, and that is going to warm things up. There's going to be increased kinetic energy, increased warmth. The particle is going to move faster and faster and faster until hydrogens are going to collide so fast that when they hit each other, they form helium. Okay, and that is fusion. And the protostar is the early star just before it forms an actual star and fusing. And then we have a star which is fusing hydrogen for a long period. Our star, for example, is going to be about 10 billion years, and this is called the main sequence stage. And in this main sequence stage, we have a scenario where the explosions of the star are pushing outwards in all directions. That's pressure. But the mass of the star is pulling inwards with gravity. And so we have gravity pulling inwards. And the beauty about this is in the main sequence stage, these two forces are balanced. Okay, so gravity, pressure, each trying to win, but neither the lesser. Okay, the main sequence stage will happen until the hydrogen runs out, and then there will be an explosion, and our sun would form a red giant, and in that the heavier atoms would be made, and if it was much a greater mass, you would have a supernova, and you would get the heavy elements. In terms of our solar system forming, just to recap, we have the sun here, and then around it we have this dust clouds, okay, which are spinning and spinning and spinning, and as they spin, the dust clouds, a bit like making a snowball, actually form discs, and then these discs develop, making a snowball bigger and bigger and bigger into the planets. Okay, and so these are called accretionary disks. Okay, don't need to necessarily know that. Okay, but the planets form by the formation of these disks into spheres, and they obviously, so if that was Mercury, next you'd have Venus, and then you'd have the Earth, etc., etc., etc. Okay, so the task there was to ask some questions that allow you to tell that narrative. So, for example, what do we call an early star, a protostar? What are the atoms that fuse together to form helium, hydrogen? Okay, so that was that question. Okay, and once again, apologies for it being a bit abstract. Okay, we next come to the question here, which is about the satellites. Okay, so here, once again, it can be a little confusing. We've got some information about satellites, and this is actually just mass manipulation. Okay, so the apogee is the biggest distance to the satellite from the Earth. So if we've got the Earth here, okay, the apogee is the biggest distance, for example, as it's going around. Okay, and then the perigee is the smallest distance, and so imagine if this just comes a little closer there. Okay, so that might be the biggest distance, and that might be the smallest distance. Okay, and the period in minutes is how long it takes to orbit. Okay, these questions here, A, B, and C, are just mass manipulation. Calculate the average distance from the centre of the Earth for each of the satellites. So the apogee given here is actually from the surface of the Earth. So in order to find out the average distance for each satellite, you need to add 35,789 plus the radius of the Earth, which is 6,378, and the other, the perigee, which is 35,782 plus 6,378, okay, and divide by 2, and the answer you'll get is 42,164. We can see on the right hand side there. Okay, so just to be clear about what I've just done there, if you look at the Earth, let's get this up there. So the average distance is from the centre out to the furthest, and so that's distance 1, and then to the centre to the shortest distance, that's 2. We add them together and divide by 2 to get the average. Okay, in terms of the period and the average speed, we've got a circumference of a circle is 2 pi r. So if we rub this out, so the circumference of a circle is 2 pi r, and so that's 2 times pi times the average, which is 42,164. Okay, but it's actually asked for meters per second. So that's 42,164 kilometers. So we need to times that by 1,000 to get that into meters. And if you calculate that, you get an answer which is, for the first one, 3,073 meters per second. And then obviously you do the same with the averages. You now what I should actually say there is that in order to get 3,073, you have to multiply the period, which is 1,436, times 60 to get seconds. So you have a scenario where you've got 2 times pi times 42,164 times 1,000 to get into meters, and then divided by 1,436 times 60, which is 3,073. And so that's how you do the maths manipulation questions there. In terms of using a large piece of paper to draw a scale diagram to sketch the orbits, that actually is obviously a task. I'm not sure if you were able to do that, but if you look at the answers here, you'll see that. Let's get this. These details up. I think it gives us the centimetres on the sheet. That's just doing a scale map of how far out they are from the orbits. So in this case, we'd have a scale diagram of the Earth, and then one orbit, and the next, and the next, and the next. Okay.